people, in the future we're going to talk about the day 3 of security. It's about a bit of authentication. Or you know what, this is just bothering me because authentication is not for today. It's just kind of authentication. Let's write encryption. What? Encryption. Yeah, that is better. So today we're going to talk about encryption. We use hashing and password cracking and user authentication. Okay. So encryption vs hacking, vs hashing. Let's talk together now again. Who remembers HTTPS? What is it and how does it work? Do you remember that?
Hypertext transfer protocols.
Yeah, it stands. Yeah, it stands for with hypertext, blah blah blah. But what is it? What does it do? If someone asks you.
Basically used for transferring data.
It is for transferring data. What?
Said.
What did you say? Just one more time.
I said it's like for transmitting data.
Yeah.
Transferring.
Yeah. Exactly.
Over the internet. Mostly.
Yeah. Yeah. But what is this HTTPS and we have HTTP? Well, what could be the difference?
S stands for security. It prevents hacking and
Yeah.
interventing on data.
Exactly. Exactly. I draw this for you, I think. Let me find it. Yeah, it's for transmitting data, as you guys said. It's for securing transmitting data. And I've drawn this a lot, and I'm gonna do it anyway again. I can't give me the bigger one. But is there more bigger? Okay. So there is a server somewhere in the internet, and this is the client sending a request. It could be from your mobile phone, you're logging into an Instagram, checking a website or whatever, to some server. And when you make this logging in your bank account, HTTPS, what it does, before the request goes to the internet, because we've talked about man in the middle, do you remember that? So there are servers in between, even there are some sneaky people in the middle that they can check what is the request is going. And HTTPS, what it does before it goes, because when you put your credential here, username, password, without S, it goes as a raw data. Raw data means as you just typed it, like your password is 123, they can see, oh, there is someone logging into the bank, Postbank or Haspa.de, and they have a username and with password 123. These people can see that. But with HTTPS, before it goes through the internet, it will be encrypted, so to say, and your raw password will be a very long garbage that no one can understand that. Yeah, when it goes there, they can still see that, but they cannot see what is the real data. Yeah, that's the HTTPS. So let me keep this here. Maybe I need more drawing. H for transmitting data. When you transfer data or request, the data is encrypted in transit. Yeah. Nobody can read your password when it's being passed online. Your password arrives to the server and server can read it. The server can compare the input to the one stored in the database. So it's encrypted, goes, and in the server is decrypted again and can compare it, okay, who is this password and so on. In another word, the communication is encrypted. Okay, security has a different layers. Is something that needs to be in layers actually. A sad truth to tell you is many users' databases have been stolen or leaked. A lot of them. Okay, they are not just even small companies, including very large companies like Dropbox, LinkedIn, Twitter, or nowadays they call it X, and a lot of them. Netflix, I can say. Netflix, so easy. It's just, I don't know, still so far. There is a concept of, let me do a search. Where did it go? Yeah, here. There is a concept of, what was it? Mother of all breaches. Yeah. If you search about the mother of all breaches, there was, is it recorded, 26 billion found online. Let me read it. I need to just read a short. Not good article. Mother of all breaches, or MOAP, exposes 26 billion records. So the story is that there was an unknown person in the last year, 2024, I think. He or she, we don't know still, and nobody knows that it was storing and recording all the username and password of millions, billions of the account, every type of account, for real people, real passwords, real, that they were leaked, yeah, somewhere in the internet. It was just gathering them and putting them in some server, in just internet. So it was like a GitHub repository, imagine it, something like that. And the funny thing is that deliberately, or I don't know, not deliberately, just forgot to just put a password on that page or whatever. So everybody could go to that page and see 26 billion list of, like, J password, email, and this one. J has this Netflix account with this password, for example. Imagine it like this. You could search, actually. It was very categorized. You could search people's name and so on with their accounts and password there. And he was selling this information to a point, and then suddenly he just goes away and leaves the door open for these 26 billion exposes accounts and passwords. And suddenly, just by chance, some security people They just find it. They just find it, and then it was in the headlines and news and so on. They could just close that, just remove that page actually from the internet. So if you knew about this page, you could access to a lot of passwords and accounts. So billions, 26 billion. So definitely could be your accounts also there. It was they called it mother of all breaches. They don't know still who was that person. And you can see it's from January 2024. It's a very new thing. Yeah. Yeah, unfortunately there are these things. If you want to check actually if your email is exposed or not, you can check that. There are platforms to do it. Let me see. So this website, have I been pwned.com, or I don't know. If you put your Gmail here, you can see I have been 3 times data breaches. So in the word 3 times they could access to my Gmail. They just could get in and they know my password. So 3 times, but I've changed my password a lot. You can check it if yours was. That's why you have to change your password and have a strong password. I have another email. Okay, this one was 0 breaches. Yeah, you can check it on your side if you want. The Lazarus group, the most brutal hackers, I believe, WannaCry ransom attack. Yeah, WannaCry ransom attack in 2017. I think we talked about it. It was a ransom attack. They were just blocking all the systems, and they were asking, "Hey, give us a Bitcoin, and we give you the password to open your system." That was something like that. Yeah. So unfortunately, these things exist. Yeah. So it is like if your LinkedIn password leaks, attackers will try to log into your Gmail, Netflix, bank using it. Because let's say they know the password of your LinkedIn, they use the same password to log into the Gmail, to test it if you are using the same password or not, to log into Netflix, to log into banks. So you are not using the same password in many places, are you? Because I do. So it's so dangerous. You have to have actually different passwords for different accounts and so on. It's not enough to secure data in transit of HTTPS. It's not really enough, because data should be secure even at rest. At rest means when you send your data somewhere, they have your information. Yeah. For example, you've registered in Amazon, you've registered in Netflix, so they have your data somewhere in their database. Also, it should be there as a secure way, because in the transit, when you transmit the data, the HTTPS, okay, it makes it encryption, no one can see while you make the request. But what if when it goes there to the server and then they decrypt it and they say, okay, this is the password, this is one, and save it to the database? What happens if it's inside of the database? What if the database is stolen? Yeah? If a database constant is stolen, what would you do? It should really not be possible to simply read passwords as plain text. The other data, such as email addresses, usually are plain text. So you usually save usernames as it is, you save email as it is in the database. But the passwords, we don't save it as a plain text. We kind of change it. Yeah. Before we go to like how we do these things and so on, I would like to talk about encryption, and I would like to talk about a bit about also hashing and what is the difference between them and so on. Okay. Have you heard about them, encryption and hashing? Any word or anything? Okay, I see some emoji of no.
I didn't get the question.
Yeah.
Yeah, what was the question again?
The question is, have you heard about encryption, hashing? Is it familiar to you or anything?
Yeah, and
We
about.
have heard of encryption, but not hashing.
But not hashing, but you've heard about encryption. Yeah? Great. Yeah, then let's talk about it. For example, encryption, you know, it could be, you know, you just encrypt something. Yeah. But the differences between them, let's say encryption is reversible. Reversible, like whatever you encrypt, you can decrypt, so to say. For example, I like cats. If you encrypt it, you can encrypt it in this way. And this means cat. I like cats. You can like reverse it, so to say. And for example, if you reverse this thing, it will be I like cats. This is reversible. Hashing is not reversible. And I like cats, when you hash that, it looks like something like this. And then if you want to like reverse it, you cannot. If you want to see what was this, it cannot be reverted. Okay? Come on. There are many different encryption algorithms. Okay? Let's say the one used above, this one, is not a serious one actually, but for demonstration it is good. Okay, let's experiment that. Where is the browser? Okay. If you go to root13.com, there are different ways of encryption. And look what you notice. I like cats. Okay? This is the encryption version of like I like cats. The algorithm that Root13 uses, it's very actually simple. If I do this and to decrypt it, it will be vice versa. I like cats. If I type A equals to N. If I type B equals to O. C. Who can guess how could be this algorithm for encrypting? If A is gonna be converted to N, B to O, C to P. No one? Any guess?
Like the position of A is 1 and the position of N is 14. So like 1 plus 13. Then B is 2, so 2 plus 13.
Exactly. Exactly. That's correct. The root 13 is like the algorithm, very simple one, that whatever you type as a character, it takes it the next 13 characters. So N, for example, whatever is the position of that 13, like next 13 character, will be replaced by that. Yeah, so A equals to N, B equals to O, C equals to P, and so on. And that's how the encryption works. I lie. Funny. Yeah, this is I love funny bunny. I is we actually. Yeah, and it's reversible. If I take this and put it here, it's just you have to reverse it back again to 13 character back each character, then it gives you that. All right, this is actually a very simple one. And if you want to write a function for that, it's just pretty easy to do it. Yeah, I wanted to make it as a task for you, but just it's okay. So this is very important to know. Encryption is reversible. No matter which kind of algorithm or math behind the scene is written, you can reverse it back. Root 13 is, so let's experiment. Let me put it actually here that you can have it as a resource if you want to play with it. Yeah. So root 13 is a very simple algorithm. Okay, it's a very simple one actually. And most encryption algorithms use a secret to encrypt. A secret means like it's just closer, or what I mean is just closer to how the HTTP works. Okay, let's experiment something else actually. Let's say A. Let's encrypt that. So A looks like this. This is A. It's using RAS 256 byte encryption. There are different ones and they use different algorithms. This is a lot of mathematics behind the scene. I really don't know how, nobody knows. But the way that they do it, it's kind of in a secret, so to say, way. And it's exactly the way that how the HTTPS works. When you type your username and password, let's say 1234, when you transmit the data, it won't be look like 1234. HTTPS makes it something to look like something like this. This is 1234 now. Yeah, and as we talked about it, it's reversible. So if I, sorry for that, if I take this and then make this empty, if I decrypt if I have something like this, and if I know with which algorithm what was created, it's created based on AES 256 CBC and blah blah blah. I can decrypt it, and it will be telling me the raw actually value of that, which is 1234. If I have I love funny, okay. If I encrypt this, you can see it's more now longer, so to say. we can decrypt it. So if I have such a garbage encrypted text, if I know based on what is encrypted, I can decrypt it, and it gives me I love a funny bunny. All right, so there are more algorithms, more complicated than Good 13, so to say, out there. And yeah, as I said, it's just kind of how the HTTPS works, is behind the scene. The secret is what the client and server agrees on, because as I said, you need to know based on which algorithm this encryption was made. Yeah, for example, this was based on AES 256 CBC. This will be, if the HTTPS uses this thing to encrypt your data when transmitting your request to some server, it also puts some bunch of information inside that that the server only can read, that which method I've used, which algorithm I've used to make this, for example, encrypted, to make this beautiful password to make it encrypted. And the server knows that secret and say, oh, okay, you use this, then I can decrypt it, what is behind the scene. This is something happens between client and server. That's how they communicate together. Client encrypts using secret, and server decrypts using the secret. Okay? The only thing that I want you to remember is this one, that I'm just emphasizing, and that encryption can be reversed. I have written it also here. So it can be easily reversed, because we don't have that a lot of encryption methods. It's just 10, 20, it's not that much, maybe 100. And with a for loop, you can just use those to decrypt something. You check that. If it's not that encryption, you check that and that and that. Finally, you find what was the algorithm behind the scenes. It will be decrypted. So it's done pretty easily. So about hashing, we talked about hashing is not reversible. So if you type something like this, if you hash this, it will look like something like that. And then if you try to reverse back what is it actually, you cannot. It's not possible. The same input always creates the same output. Okay, so when you type this, always the hashed version of it is this, always. The output, whatever it is, we call it hash. So whatever you get as a hashed thing, so in this case you call this hash. Okay, and also for hashing there are different way of algorithms. Let's have some again experiment. So for creating hashes, so there's a website generating hashes. SHA-1, SHA-256, SHA-512, MD5, for example. There are different algorithms. Behind the scene, whoever created that is just mathematics, complex math to create something like that. Yeah, I'm going to choose MD5 for now. And let's say I like cats. This is the hashed version, and it's all the same output. It gives you always the same result or hash. If I take it, look at that. If I put it again, it's 39B at the end. If I take it and put it again, 39B. So this is always the same for I like cats if you use MD5 algorithm. Yeah. So what if I use something like I only? it looks like this. And you've noticed that the length of the hashing never changes. It doesn't matter how big is your text. Behind the scene, when it's gonna be hashed to something, it's always the same length. The MD5 uses 32 characters. If you count this, it's 32 hexadecimal characters, like numbers and text together, letters. If it's even one letter, it's the same of 32 characters. If it's, I don't know, thousands of lines, again it's that. Okay, this is the hashing. And the good thing is, for example, SHA 256, because we have different one. MD5 is a dead one. It's easily, like, you don't want this algorithm for creating hashes. It's much easier, like nowadays you can crack this, so to say. There are different other one. SHA1 is not, it's not commonly used. Yeah, the commonly used one is 256. I think this one is used for military security. So if you have a military, I don't know, and you want to be very secure, you're going to use this algorithm. We're going to use a 256 also. This is very secure. And you can see it gives you a longer one and more secure one, and also it's the same. I think it's 64 character, or I don't know really, but you can count it. If you type A, it gives you this hash. If you type AB, this hash. And always AB is this hash if you use SHA 256. You can see 603 at the end. If I delete it, and if I type again AB, it's 603 at the end. So this represents, this represents AB, okay? Or ABD, this represents ABD. Or if I say I like cats, this means I like cats, actually. It's not reversible. You cannot reverse it. You cannot reverse this to get a raw text like that, because it's a hash. Yeah, it's the thing is that the length never changes. It's always, it doesn't matter. It could be thousands of lines. The length of the created hash is always the same. Yeah, that's kind of hashing, so to say. Yeah, as we talked about it, example of a basic hashing is SHA 256 that you've seen it. If you want to build something, if you want to really like secure your data, use something like SHA something like 256, 500 or something, or those that they start with AES and something. Okay, these are the algorithms for creating hashes and very secure one. And if you see MD5, just don't use it anymore. It just doesn't work. Okay. And as I said before, it's like military grade encryption equals to something like AES 256 or SHA 512. They are using like very secure one, these ones. All right, now you know what is hashing and encryption. The main thing is it's not reversible, it is reversible. Yeah. Passwords should always be hashed. So when you saving a data from your users into the database, you don't want to save the password, the raw passwords in your database. You want to save and replace it with the hashed ones. So you're gonna, so to say, convert the raw password to a hash password and then save it to a database. You do not want to encrypt password, because encryption is reversible easily, but the hash passwords are not reversible. Okay, the reason is that if someone steals your database, they cannot simply decrypt the password because it's hashed. And this way, it's much slower and harder to access to actual passwords. But still not impossible. Okay? Because the passwords can be cracked. So far, is this clear what I'm telling? Any question? Yeah? Okay, fantastic. Password cracking exists. It can take time, but exists. You receive a list of user accounts with hashed passwords. Something like this. You could able to steal, or a hacker or someone could steal your database or any database of the users. And user Ace has this password. This is a hashed password actually. The good thing is, the first good thing is, we cannot see the raw password because behind the scene it could be something, I don't know, a raw password like hello. Maybe the password is this one, we don't know, but it was hashed. And also the password of user Pam is Jim is hashed. The first good thing is that if we get access to this data, the password is hashed, we don't know, okay, still. But the next thing is that we cannot anyway decrypt it because it's hash, it's not encryption, yeah. You cannot decrypt them, but you recognize the algorithm is MD5. How you know it? Because the MD5 uses 32 characters. This 32 character, you know, okay, if they used MD5 to hash the user's passwords, then maybe I can not decrypt it, but I can maybe find the password, like crack the password. Lucky, that's a bad one for passwords, because MD5 is just pretty easy to also crack, yeah? And you would say, okay, because being a hacker, or to be a good hacker, you should be, so despite knowing all the skills and so on, you should be really creative. Yeah, you need to guess some stuff by your brain. You also know the 3 common passwords that we use always. There are a lot out there, common ones, and the common ones that the people use is 1 2 3 4 5 password 1 2 3 4 5 6 7 8. So these things are existing there. And what if you just give it a try and say, you know what, let me try this, maybe I can find one of them has these passwords. You would say, you would try something like this. Hey, MD5 algorithm, what is the hash version of this one? 1 2 3 4 5 6, and then it gives you something like that, 3E at the end, and you check, okay, it doesn't match of one of these. Let me try something else then. What if I try, hey MD5, try this common password, because a lot of people use the keyword password as their password, and if you try to do this, and it gives you, MD5 gives you the hash form of the password, and it looks like F99 at the end. And look at that. It seems A's password is password. In this way, they can understand A's password. The username A's has the password, and they can log in to their system. Yeah, there will be. Let's check also this one, 1 2 3 4 7 8, and then we check it. Okay, none of them has that. See, this is just a loop that you can run and check one by one of common passwords, I don't know, leaked passwords, if you know the algorithm, maybe it was MD5 they used. Okay? Yeah. In this case, wow, looks like password for ACE is the password, actually, the pass keyword. This is actually an example of password cracking using a dictionary attack. Okay? The dictionary attack is like, Okila says, what does MongoDB UUID use to generate unique IDs? It uses object IDs, and it has nothing to do with hashing. The object ID of the MongoDB is, let's say, this is the ID that the MongoDB creates for you. It's, if you check, there are some dots in between of that. I think there are 3 parts. Those 3 parts are different algorithms that they use. For example, the first one for the object ID, I think they use the date, like date.now. This thing is using a random generator of mathematics stuff, and this thing also using a random generating. You know what, let me just ask, I don't remember it, but it's not using a hashed one. It's just creating a unique ID, and it has nothing to do with a hash thingy. Copilot, explain. Wait, I haven't asked anything. Object ID in MongoDB, what is it consist of? Let's see. Yeah, as I said, there is 3 parts of that. The first part is timestamp, which is date.now. When was that created? The middle part is a random value. It uses a unique random value, so to say. And the third part is incremental counter unique. It's like, based on the database, it will be just adding 1 to that. I will show you what does that mean. It's not hashing, actually, so to say. It's the data, the MongoDB uses a very clever way of creating a unique ID, which is just a random text, so to say. All right. Good question. Yeah. So password cracking, when you see it in the movies and so on, how they do it, they crack the password. They have a list of billions common used passwords. It's just a normal text, billions of them. And you have a list of millions of billions of common passwords. You hash each of them one by one and compare the hash to the passwords. So let's say you have a list of, I think I have a list of them as an example somewhere here. So that's just an example, yeah? 10,000s of a password I just paste here. It's not that much, but 10,000s of common passwords. And what you would do, so what they do as a cracking a password, they have a list of passwords, they write a loop, and they try to create a hash password out of it. Like they hash this one, hash this one, hash this one. And when they hash one by one, they compare it with the list of the users that they have. And for example, the hash passwords of the keyword password was looking like this one. Yeah. So they create a hash of every password and they just try to compare it who or which user has this hash one or this one. When they find out, they say, oh, okay, the password of that was, for example, this one. Or the password of that was monkey. They cannot reverse it. They just can create a hash from that password and compare which user has this hash. And then they know what was the password. Yeah? This is how they do it behind the scene. Does that make sense what I'm telling? Yeah? Great. So if the passwords are weak, you will crack most of the accounts. Yeah? If the password is weak, it means like they use numbers, they use only letters. And these are the weak passwords, and it's just, you can have a list of it. You can find this list in the internet. You can buy millions of passwords out there exist, and you can give it a try and crack all of the password that you want, and it exists there out there. And if your password is easy, it will be crackable. Yeah. So something like some accounts might use a strong password like this, AD, and then numbers, and then letters again, and maybe special characters. A dictionary attack might not work, because if you have a list of common words, even billions, maybe it doesn't work, because they could be just real words, you know, the people they use. But what if someone uses such a password, then this list of words cannot work. It's too random. Yeah. Then you as an attacker, or as a cracker, you decide to try hash every single possible combination in the world. You would do something like this. I'm gonna hash what is A. Okay, this is A. I'm gonna hash B. Okay, this is B. I'm gonna hash C. Okay, this is C. I'm gonna hash, let's say, AB. And then it would be something like, I don't know, something like that. And etc. You're gonna hash every combination in the world that exists. And then when you hash that, then you try to again check who has these things. What I just explained, we call it brute force attack, so to say. You're brute forcing to find the password. It is very slow because we have endless, so to say, combination of words in the world. It's just endless. And very slow. Speed depends on password complexity and the computer speed. I've been watching this really a couple of years ago. The guy was sitting there to crack a password. He was working for I don't know, some FBI stuff. And like the detector, or who was it, asked this guy, how much does it take? It said, I don't know, depends on the password complexity. It could take days or months. Yeah, because you're gonna create every combination of, in the word and just compare it. Is it that? Is it that? Is it that? Is it that? So it's so difficult and it takes time. But anyway, a strong password plus good algorithm might take million years to crack. Really, million years it can take to crack. But eventually it will take, it will work. Yeah. With characters A to Z, small, A to Z, capital, 0 to 9, you have 62 possible characters. Okay? So these characters will be like something like this. AA, AB, AC, and etc. You will have, in this case, you will have to try hundreds of millions try to create examples, hashing and combination and so on. And the number of possible combination that you can create from A to Z small, A to Z capital, and 0 to 9, it's this number, which I say it's million, billion, trillion, 218 trillion possible combination. And that's a really spicy for loop if you want to run this. It takes, I don't know, years if you want to crack, but not possible. Computer can do really crazy stuff because there are really I don't know, very big computers, very high speed computers that they can do this fast. And that is not enough actually. Yeah. So I recommend, when you creating your passwords, because we've seen if you have really A, B to C and numbers, yeah, it takes 218 trillion combinations that they can crack your password. It takes really time, but what if they have a very big giant computers, they can do it very fast. Yeah. So if you want to really make it more or more difficult to be cracked, use special characters, longer letters and so on. Then it will be like almost impossible to crack. And in any case, even hash passwords can be cracked. Yeah. That's why we're telling that you should change your password sometimes or time to time. That's it. Let's build a very simple authentication. So authentication means, for now, I don't want to go deep into it, maybe tomorrow, a login system, because someone want to log in. Yeah, and then you authenticate, you give access. If everything is fine, you say, okay, come in. All right. Let's do it. That's all that I wanted to talk about. Any question? Is it these things interesting to you? Yeah, fantastic. So all of these things that I've explained is to tell you at the end, you're gonna save the user of your password, the password of your users, not like a raw password what so far we did in the database. We want to hash it first and save it to the database. All right, that's the point. So we need our server again, we need to set up our database and so on. I really want to copy and paste from our previous folders. So let me, we have your class here. So last time, I'm going to take from here. I'm going to take it from the validation security stuff. And I'm gonna paste it here. No, don't replace the notes. Skip it. Okay. Yeah, I have it, the code. I think I don't have .env. I need to create my .env. Oh, RNV? No, .env. And I have somewhere my env credentials over here. All right. Okay, let's run it. I think the packages are not installed. I would like to install all the packages. So npm I. All right, let me give it a try. npm start. Okay. Machine. Is it too small for you guys? Should I make it bigger?
Yes. Yes, a little bit.
Is it better? Or more?
Perfect.
Okay. So I forgot what we have here. We have user router models. We have user model. Let's see what our user model has. Great. We have username, password, email, bio. We were testing in our endpoint the validate user. For learning purposes, because we want to now learn the hashing and so on, I'm gonna get rid of this because we have to again put everything correctly in our input because it's validating the data. I'm gonna for now just get rid of the middleware here, and when we just finish with that we can add it again. That's it. So if we remove it, then it's won't checking all the validation stuff. And yeah, we have our user model. Fantastic. Let's see. Our user model has a username, a password, email, and bio, which is just default empty. The email must be unique and required, password must be required, and username also must be unique and required. All right. In our user router, we have getting the user, saving a user, and so on. Okay. I would like to create another endpoint for logging maybe later, because it's for registration and later we need another endpoint if they try to log in. So this is for registration anyway. Yeah, so people sending a request, a post request to just to be registered in your database. We take the data and we save it to the database. Fantastic. Let's give it a try. I want to test it if it's working. I think my REST client doesn't work because I don't have this extension. Let me install it. REST. I had a lot of extensions that I don't really remember what I had. So I think we need to install one by one of them in the middle of the way. There was also another one, React. Okay. Yeah, it's for now, it's fine. So let's create a user. Bang. Fantastic message, user successfully registered, and this is my saved in the database. New user with this one. Look at that here. The problem is this one. This is the password of Shinedu23. And we saved it as exactly as raw password. And what if my database is leaked and someone can access to my database and they say, oh, Shinedo has this password, then easily let's just log in. We don't want that. We need to replace it with the hash one. Even if it's leaked out, then they don't have access to the raw password. They have a hashed one. Now, yeah, start. If you can crack it then. You know what I mean? So that's the problem. Let's also create another one. Let's say Savin. And the password, let's say Savin uses is rabbit. Yeah. And then that's Savin email. And let's say Savin has no bio. Okay. Great. Let's create also Savin. Fantastic. We have Savin in our database. And the password of Savin is rabbit. Okay, everyone knows it now if the data is leaked. Okay, bad. If I get all of the data, everything's fine. All right. Now what? Let's begin. The thing that we need a package actually. Before I go, what time is it? 10:30 to 4 minutes we have. Before we go, did you set up? Is everything working for you? Were you able to run and everything is fine? Can you code along with me? Okay, Shinedu says no. Why, Shinedu? What's wrong?
I was not good along. I don't know if you don't mind to share the live share.
The live share you need. Okay. Unfortunately, I hear you like you have a bad connection. I cannot hear you correctly, but I've heard the live share, so I can give you the live share. Oh, is live share an extension?
Yeah, the link to the live share.
Okay. I think
Oh,
live
can
share.
you hear
Yeah, I can hear you now.
me now?
Yeah. I think live share also was an extension.
Yeah, my connection is bad.
Now it's good. It's much better now.
My connection.
Okay. So the live share is in the chat. You can have it. All right, so if it's working for you, we have still 2 minutes. We need to work with a package actually. We need a package. And the package that we want to use is, where are the browsers that I use? Come on. Oh, I closed it, okay. Recrypt npm. Okay, published a month ago. It's updated a month ago to version 6. That's good. You can see monthly download, weekly download is 2.5 million. It's a good one. And it's helping you to create hashes. So npm install And then yeah, remind me to talk about also salting, because when we create hash out of something, it will be understand. We need to know what is this salting also. So the usage is like we importing that. It's a very old way of importing. We don't import things nowadays like that. And we need a salting. Like salting is like how many times you want to hash. Yeah, this is the plain text of the password. Let's say this is your password. And another password maybe you have. And the way that you would do it, there are different ways to hash a password. That's a function, something like that, and then a callback function, and then inside there's it's so bad. I don't like it. Let's give it a try. Another one. This is much. The technique 2 is much looking like better. Bcrypt.hash. It receives your plain text, how many times, and then a callback function again. Okay, it looks better. Let's go more down. A very much better, easier way, which I love. Promises. With promises, we can hash the password. We give it the plain plain text password that we have, and how many times, and then dot then. So who can say what is the alternative to dot then? Then you have promises. If you answer this, we will go to break. This is returning a promise. You can handle promises with dot then in another way also.
Await and sync.
Yes.
Sync await.
Yes, fantastic. This dot then is an old version of like handling promises. We can get rid of that and use just this simple line, but put a await at the beginning of it. Fantastic. This little line is going to help us. And then also the comparing of that, we will come to that later. That's the one that we're going to install, yeah? Let's install it and then we go to break. Just npm I bcrypt. I'm going to copy that. I'm going to put it in the chat if you want also. So, let's install it. All right. I have installed that. So let's be back at 48. All right. See you in 15 minutes.